video we are going to see about transmission gates. A transmission gate is simply a digital controlled Cmos switch. The Cmos transmission gate consists of one NMOS and one PMOS transistor connected in parallel. The gate voltages to these transistors are also said to be complementary signals. As such, the CMOS TG, which means transmission gate, operates as a bidirectional switch between input and output terminal, which is controlled by gate voltage as like a pass transistor. The substrate terminal of NMOS transistor is connected to ground and substrate terminal of PMOS transistor is connected to VDD. A transmission gate consists of PMOS and NMOS connected in a way that transmitted the input value in one condition and blocked in other condition. The schematic diagram of the transmission gate is a controlled input which is connected to both the gate terminal, and one is normal control input and the other one is complementary controlled given input, and the input is given to source terminal and output is get from the drain terminal. This is the circuit symbol of the transmission gate. Operation of transmission gate. When the control input is high, here the gate of the PMOS transistor is high and NMOS transistor is low. If the data input is low, VGS is positive and VGS2 is 0 volt. So neither transistor is on. If data input is high, VGS1 is 0 volt and VGS2 is negative. So again neither transistor is on. So when control input is high, the device is in high impedance state. The transmission gate is a most widely used solution to deal with the voltage drop problem. It builds on the complementary properties of NMOS and PMOS. NMOS device passes a strong 0 but a weak 1, while PMOS transistor passes a strong 1 but a weak 0. The ideal approaches is used to an NMOS to pull down and a PMOS to pull up. The transmission gate combines an NMOS and PMOS device in parallel. The control signals to the CMOS gate C and C bar are complementary. When C is equal to 1, both MOSFET are on, allowing the signal to pass through the gate. A is equal to B. If C is equal to 1, then if C is equal to 0, this is the operation of TG. If C is equal to 1, it will on both the transistor, and then A is equal to B, which is nothing but output is equal to input. When the control input is low, both the transistor will if the data input is low, the VGS is 0 volt and the VGS2 is positive, and therefore Q1 is off and Q2 is on. There is always a conduction path from input to output when the current control input is low. Here is the operation of transmission gate. This is the truth table of transmission gate. Here control input is separated into C and C bar. Input C is connected directly to NMOS gate, whereas input C bar is connected to PMOS gate, where input is 0 and the output will be 0. If the input will be 1, the output will be 0 based on the control gate. Both transmission gate can be used to build some complex gates very efficiently. This truth table shows the schematic working of the transmission gate. A complementary implementation of the gate requires 8 transistors instead of 6. Thank you.